Hello again and welcome to AstroPrinter. So today we're going to do, I got a nice little gift in the mail today, and we're going to do an unboxing and setup of the Longer 3D LK1. The Longer 3D LK1 is similar to the TiVo Tornado in size. It is a 300 by 300 by 400 build area. So let's go through and see what's in the box. Chances are part of it through I'm going to take the box out of the way, just lay everything out on the table. So let's go through this. Everything seems to be well packaged. So we'll take off the first layer. Just some foam which we can discard. We have our instructions on top, which are very well laid out and appears to be very well written. So I'll just show you quickly here. And you have your instructions. I will leave those aside. Not that I'll need them, but I'll still leave them aside. Okay, so let's see what is in here. We have our nice glass build plate. Immediately comes straight into our base for the printer. So let's unhook this and get this out of here. So I'll leave that there. And we have some clips for the bed, which we will leave aside. I'm sure there's more in here. Correct. That's to the side. Next we have our box of goodies, it looks like. So let me see if I can grab these out of here. Box of components and goodies, which we will inspect in a moment. We have a whole pile of cables attached to their control box, which is actually a touch screen. And next we have our padding around. This is our Z, our X and Z axis. So let me unpack this. Easier to do it. It's very well packed. And just have a quick inspection inside to make sure I've missed nothing. I don't think I have. So I can take this packing and put it aside just for a moment. So we have our X and Z axis. It's a Bowden style printer with a single Z. Everything looks tidy. So let me start off with the base and put this aside for a moment. And we'll have a look at what's in our goodie box. So in our goodie box, we have our level cutters. I'll put those aside. We have a spatula, which is kind of blunt, but it's okay. Our power cable, USB, and that's that's our USB A to USB B. That's USB A, and this is USB B, which is like a printer style USB. We have what appears to be an end stop with some bolts. This appears to be a spare part, and I'm assuming it's some form of end stop again. So we'll come back to that. It says spare parts on the container. We have a USB with a USB adapter with a micro USB. We have a screwdriver, a little wrench, some zip ties, and the obligatory needle for cleaning your nozzle. We have some Allen wrenches and a nice starter spool of a nice purple filament, which is nice for a change. Normally it's white in most printers. This fell out of somewhere, so I'm assuming I will need it soon. And then we have our spool holder. So let me put that aside. Okay, so I'm leaving the glass bed. I'm going to move the glass bed out of here just for a moment because I do not want to knock it while I assemble the rest of the printer. So we have, this is very similar as the Creality series printers where they have, and it seems to be a lighter frame though than the Creality printers. So it's a fairly sizable X and Y, and the Z is a lot of height. It's got 400, so it's 300 by 300 by 400 in Z. So let's open up this one, I'm assuming. I know we have the instructions there, but I put together enough printers to figure stuff out. So we have one Z T bracket, which has a little end stop attached there. We have another T junction, which is again is a frame support, which I'm assuming is going to be on this side because the end stop will go on this side. Let's take this apart, empty it out. So we have a couple of large, 4 large, they look like M50s, but so I'm assuming they're going to hold the frame together. So let's get our frame set up. Get these cables out of the way, and this will sit just on there. Now, the way I like to build these is to bring it off the edge a little bit to get the first screw started. So you have 2 screws that go in that match up on Z. And I need the Allen wrench. It'll be easier if I have my Allen wrench. So just give me a quick second and I'll get out get the appropriate size Allen wrench out. It'll just make assembly easier. So put this on here. It'll freestand until I get set up. Put in the first bolt. Never tighten it down fully. Just get the first bolt in place to get it started. And then we take the second one. Get in the same situation with the second bolt on this side, and we tighten them up after we have the bolts in on both sides. Okay, it's kind of lightly tightened on that side, but not too much, because I want to get the bolts in on both sides before I fully tighten it all up. Again, hang it off the edge, get the 2 bolts, and once these are in, so this doesn't seem to be fitting together, so I think I know why. So what I'm going to do is I'm going to move the Z up, because this seems to be pulling it together. And these little retention bolts are probably what's causing it. So let me remove these tension bolts first, because it's putting a bit of a squeeze at the bottom of the Z-axis. Put those aside. I'm going to move my Z up higher. Excuse me. Okay, now with that up, out of my way, I'll have a bit more flexure in assigning this there. I'm going to tilt it over on its side. See why these are not lining up. Again, I'm assuming they kind of do line up now. There we go. Just need a little bit of coaxing. Let's get these started and I'll move on and I'll tighten these up then. So get a little bit of tension on each of these. These screws, I'll show them to you in one moment. Move that out of the way. So the 4 screws I'm referring to are these 2 that come right up into the space, and they need a little bit coaxing to get them into the right spot, and that's been done now. So I'll take those out of my way. Bit of grease on my fingers from touching the Z screw. Okay, now we have an end stop, which I'm assuming goes in here, which triggers your Z axis coming down. And then I'll have another one of these brackets like this one that goes on the opposite side to support your Z and X frame. Assuming these are all the same, so I will need this other Allen key or hex key. Get that started. There are 4 screws on this side. Sorry, that's blocking your view, I'm sorry. So these 4 screws act as supports, but they also hold the Z end stop. There's a little trigger over here, which you'll see in a moment. And unusually, actually, they've actually put retention bolts on the X-axis and the Z to hold it in place during shipping, which is nice, but I haven't seen others do that. So that's a nice addition. But it's something you have to remember when you're taking it apart. The one thing I do like is they've given the hex wrenches, or Allen keys as some people call them, with the ball ends on them. So they actually have a little rounded ends on them, which is actually quite nice. Normally they don't have that. Normally they're just flat ends and it's not as nice to use. So on the other side of the axis, we have these 4 screws, which will then attach to here. Again, it's tapped into the frame, which means you're not dealing with T-nuts and so on, which is actually a nice addition. Well, there's good and bad in it, I suppose. The good is you don't have to deal with the T-nuts. The bad is if anything goes wrong, or if the threads get stripped or whatever that's in the frame, you can't replace it. You can't replace it because it's built into the frame. So there's plus and minus. Now this is very, very similar to the Tivo Tornado in design, and the CR10 is very, very similar in the design. Even the way they connect to the box is similar. They're using airplane connections, which we'll go show in a moment. But assembly is pretty fast. Okay, so that's the main frame put together, minus the spool holder, which we will address in a moment. So, let me turn this around and let you see the setup. Now, the one thing I like that the hotbed connector can be removed, so that's a nice addition. One thing I do not like about it is there's no support for this connector. So there's very little support over here for this connector when you're using it. So let's get our control box. I'm going to turn that to the side and park this here. And before I kick anything off, I'm going to remove the warning label and make sure the voltage here is set to 110. It's set to 230 because it's so we remove that to 115. The reason why by default it's at 230 is if you plug in, if you plug this in Europe, it will power on. If you plug it in here in the US, it will not power on, and the voltage is set so high it will not go. You will not blow the board. If it was set to 115 and you plugged a 210 or a 220 in here in Europe, you'll fry the system, and therefore you'll end up leaving out the magic smoke, and your printer won't work. So let's turn around and have a look at these cables. Make sure everything's well labeled. So it's X minus, E minus, and then we have E, MOT for motor, and X motor. So X and these are going on the other side. So let's quickly realign some stuff. Because this is X and Y, and E, they're all on this side, so we need them over here. So we have our E motor. This is our extruder. We plug it in right here. Now there's also an E minus. The E minus is your filament runout sensor, which you have here on top. Let me turn that a little bit easier. You have it right here on top. There's a filament runout sensor. I think it's optical, but let's plug in the E minus. Then we have our X MOT. This is our X carriage. So our X carriage gets plugged in here. And then we have an X minus. X minus is our end stop, which is plugged right in here. Kind of like a tight fit, but it's okay. X minus is done. Now we'll take the other end of this cable and see what we have here. We have our Y minus and our Y motor, so that goes at the back. Our Y stepper motor is back here, so we lift it up and plug it in underneath. And our Y minus is our end stop for our Y, which is back here. And then again, it's a kind of a tight fit, but we will finagle a few things around and get it in there. Okay. And then we have our Z motor, which plugs in right here to the back here of the stepper. And finally, we have our Z end stop, or Z minus, which plugs in. Let me pull this out of the way. I don't like that, because I'm going to reroute that underneath because it's too tight. And then we have our end stop, which plugs in up underneath down here, which is kind of hard to reach, but so your end stop plugs in under here, which is your Z minus. So that's kind of not leaving a lot of slack on the cables. It's kind of a tight fit. It'll work, but it's kind of a little bit of a tight fit. So next we have our airplane connectors. So we have two. One for the hotbed, which is 4 ports. So we'll bring that over behind the printer. And there's one here for 4 ports, so we'll bring that onto that and plug it in. And again, these are keyed. And you just screw it in place. And then we have our extruder assembly set up, which has multiple ports, 8 ports. And this one goes into the next one, which is the one on the left if you're behind it. Again, it's keyed. Let's be sure to get it in the right way around. Yep, and screw it into place. Now they mount the extruder, they mount the filament sensor or filament spool holder on top is the way they want to mount it. I'm assuming I'm going to mount it to the back because your filament sensor is here at the back. So let me find the right Allen key for that. I can mount it up here. That's our spool holder in place. Next we have to attach the bed. So let's see who's... So let's get our bed. This is longer bed. And it's a nice finish. So I'm going to print directly onto the glass here. I'm only printing PLA today. We have the 4 clips, which are kind of old style nowadays. Most companies now are starting to add the ability to add built-in bed clips. And I'm going to do an inspection of the bed underneath in a moment. Before we kick off our first job, I'm going to move that in a little bit. And we'll have a quick inspection. So let me have a look underneath the bed. Okay, so the bed, the underside of the bed is not insulated. It is a heated bed, but there's no insulation in there. Now, that's not a good thing. It's harder for a bed to maintain temperature when you have nothing underneath to heat. So I would highly recommend it needs a heated bed underneath. You can always buy heated beds for them, but for now, we'll run it as is. So let me get everything else wired up. So I have the power cable. I have a power cable from an existing printer back here. And I did change the power to 115. So I'll get it plugged in. Oh, it was already on. Okay, so let's power it up. Nice display. So let's say we go to move head. X moves. Y is moving. The belts seem to be a bit loose, but I'm going to leave it as is. I'm not going to tension anything right now. And let's check our Z-axis. So everything's moving, which is a good sign. So let's go back to our little bit of filament that we have. I really do not like this delivery of filament to anybody. It's a bad idea. There's so little in it, and it can easily get knotted. I really do not like this. Companies need to get out of doing this. They need to go back using the small spools. Many companies supply filament in spools like this. This is the way to do it, not this. I'm sorry. I have a real problem with this. But we'll use it for now because it's what came with the printer. And I'm not going to, I need to level the bed yet, but I'm going to get everything started off. And I need to straighten this a little bit, just to get it in place. There we go. Okay, so I'm going to first thing I'm going to do is screw all of these down, because they're often a little bit too high. And I want to screw them down because I do not want the head impacting the bed. And I'm going to do a first leveling cold. And the reason why I'm doing my first leveling cold is I do not want to run a hot nozzle into the bed. So I'm going to screw these down to tighten them up a little bit, to give some separation between the nozzle and the bed, and then I'll bring it up cold. Then I'll heat the hot end and redo it again when everything's warm. Now there is a big rock. Actually, I do not like that. Look at that shaky bed. So while this is, let me turn that off for a second. Let me see what we can do about that. So underneath the bed, there are 6 wheels, and they are not contacting. You see the way this is spinning without even moving the bed? This one is spinning. This one is freeing. This is free. So these are not concentric nuts, but the ones underneath here are. So to cure that, we'll get our wrench, and we're going to adjust these to get them nice and tight. So you want to adjust them until the wheels move so they're engaging the bed but not too tight. There you go, there's one. See, I can move the wheel a little bit. There you go. The second one is loose. So I'm going to go to each of these wheels, and the bed should move when I turn them, but it should not be tight to turn them. Okay, and then the last one again is a bit loose. This is okay. The new concentric nuts are only on one side. Okay, that's a lot better. So let's check our x-axis. Our axis, now there's a lot less wobble in that. That was really wobbly a while ago. Now we're in a better situation. Let's power back on again. And I do not like all these cables. It really needs a cable organization setup. I'll probably clamp these together. Actually, I have a zip tie here, so let me go do that now. Let's clamp these together, because all of this stuff wobbling around there is just not good. All the way over. The newer designs are coming out with, newer printer designs are coming out with less cabling to deal with. And I think it's a good thing. There's good and bad in it. The good is it's tidier to set up. There we go. Let's snip that off. Now it's tidier and out of my way. So now we have it powered on. So the first thing we're going to do, let me go into the menu. I'm going to tilt this up here for you, so you can see, and I can see from the side here. So we have move head, files, extrude, preheating. Go to move head, and there is a home button. The red home button is for all. There's a home X, there's a home Y, and there's a home Z. So we're going to do the red home button to home all axes. Hacking fluff. Oh, that's not good. So our end stop is not working. Let me have a look from this side. Oh, I see what the issue is. The belt is getting in its own way. So let me see if I can snip that off and make it fit better, because the belt is actually hindering its own movement. There's an extra excess on the belt, and these belts a little bit extra. The problem with these belts is now it's moving and it's impacting. Let's see if this is wobbling. Okay, that's not moving. So let's try this again. Let's power it back up. We're going to go to move head again. I'm going to do the right home. That's more like it. Now, one thing I've noticed, the belt is actually held on with zip ties. So it's folded over on itself and actually held together with zip ties. I didn't think people did that anymore, but apparently some are still doing that. I do not like that type of setup. So let this home, and while this is homing, I'm going to get a sheet of paper, because I'll need this for leveling. Okay, so we're homed, and now we're well off the bed, which is a good thing. So I'm going to loosen this up and bring it up to roughly where, I'm going to loosen this and bring it up roughly where my nozzle is touching. Okay, it's touching there, so I'm going to back it off a little bit. Okay, just lightly touching, and that's good enough for now. So I'm gonna actually go in, and there's a little padlock here, and if you click that, it disables the stepper motors and allows me to manually slide my axis over the bed, and do the same on this side. And remember, this is my rough alignment. I will do a proper bed leveling once I get it roughly done. Okay, it's impacting there a little bit much. Okay, now I'm going to do the same at the back of the, slide the y-axis forward slowly. Do the same back here. Okay, that's slightly touching, and then move all the way back over to here, to the edge of the bed, and loosen this one up. Okay, we're leveled. So I'm going to home again, and now I'm going to heat the bed, and I'm going to and the extruder, and get it ready for some filament. So I'm going to go backwards, and I'm going to go to, it says preheating, and I'm just going to use, they have preheats already in there for PLA, ABS and PETG. I'm just going to use the PLA one. I'm going to hit preheat. So the preheat is 60 on the bed and 220 on the nozzle. That's okay for PLA. So let's see how fast it's heating. Now this is heating pretty fast. It's already up to 44, 46, 50 degrees. 25 in the bed. 26. bed seems to be struggling a little bit to get up now, so 27. So let's wait, let that run for a small bit of time. And while that heats up, let's get our SD card. Not that we're going to use it yet, but we'll let everything heat up. Make sure it's ready. The SD card goes in here on the side. Normally they go in upside down. Oh, this way is right way up. Oh, is it? No, it's upside down. Okay. So we'll leave this a few moments, let it warm up. Okay, so we're near temperature. We're at 200 on the nozzle. We're at 47 on the bed. So the bed is taking a little bit of time to warm up, but you can actually feel it warming up. So the next thing we need to do is load filament. So let's turn around. I like to manually push the filament through, so I like to squeeze the extruder and just feed in the filament that I want. You can see it going down through the tube there, down into the extruder. But this doesn't give a lot of material. So before I do that, I'm going to go back out and I'm going to change my Z position and increase my Z height. I want a little bit of height on it, because I want to have room for the oozing filament to come out through the nozzle and be sure it's working. So I'll just release that and I'll feed some manually in. And there's some black PLA already in it by the looks of it. There comes my purple filament. Using my tweezers, get some of the material, knock it out of the way. There's a blob on there. Oh no! The nozzle actually melted a hole in the bed. So the bed is got some sort of soft material on the surface. I want to tighten these down a little bit more. That is, when these leveled, it actually burnt a little hole in the bed. So this material melts with the nozzle. So I'm guessing it's some sort of soft plastic layer on top. That's kind of disappointing. So let me clean off my nozzle one more time. Okay. So since I have this, I'm going to home it again with a bit more space here, because I'm worried about it burning again. I'm going to do a home, and this time there should be a gap. I unlock so I can move my axes. Slightly rubbing, that's where it should be. There should be no real drag. Move it over to the other side. A bit tight, so I'm going to tighten this down a little bit. Okay, we come back here. Lightly rubbing. So that's, I'm surprised about that they put a nice glass bed on it and then they cover the bed with a material that can melt. Doesn't make a lot of sense. Why would you do that? Because it is glass. So, okay. So I'm going to home my Z again, home everything again. Make sure that doesn't get stuck and burn anything. That should be okay. So I'm going to go back. I'm going to go to Files. And let's see what files they have in here for me. So they have whistle code, small square, how bad, I don't know what that is. So let's do the small square. And hit open. And hit yes. So now we're going to watch as it puts on the first layer. The first layer is going down. It seems to be going down okay. And it seems to be making a raft for it. But this is kind of disappointing that this is the outcome. I would never have built a bed like that. So you need to be super careful when you're leveling your bed, because once the nozzle is hot and it's resting over any area of the bed for any period of time, you run the risk of the heat of the nozzle actually burning and melting the bed, and it did just there. And this is only PLA. So if you're doing at 200 degrees for PLA, if you were printing PETG or ABS, it would actually do even more damage because the nozzle would get hotter. So the first layers seem to be going down okay. I'm going to let this run, and when it's done I'll come back to you and we'll have a look at the results. So let's talk about quality of the prints. So this is the first piece I printed. It comes on the SD card. The print quality is quite good. I measured dimensionally. It's not perfect, but it's close. It can easily be fixed with a few tweaks. There's a slight bit of ringing along the surface here, but not too much. Might be able to see there if I get the right angle of the light. So that came out okay. So I decided, and this is the purple filament that actually came with the printer. So I decided to print some of these cubes, and there's a few other components on it, but it didn't come out great. This one came out the best, and it's just because of the printer settings again. So this cube is actually created by the 3D printing professor. So I decided to print this, and did it fit? It did. It wasn't great, but because the print wasn't great anyway, so I decided I wanted to upsize it and try it again. So I upsized it, and when I upsized it, I got the print quality was a bit better. Again, it needed to be tightened up. These components some of the components did fit together, some of them did not. There is some discoloration here, it's because I was changing filament colors. but they did not all fit. Did not want to fit together, so I decided it was over extrusion, and even these smaller components, they wouldn't actually really plug in together. It was kind of a struggle to get them to try and even join at all. So I downsized it to original size again, which is similar to the small white ones. And when I downsized it, they actually started fitting. Now, they fitted well. The components do go together. They do fit into each other, as you can see here. And what I did to make that work was I dropped the extrusion rate down by 1%. So it went from 100% extrusion rate down to 99% during the print. And that actually gave a better quality, a better fit. So it is over extruding, and that's easy enough to fix with calibrating E-steps, which I did not do. I used everything stock. So I decided to print another item from the SD card. This is, they call this an angel. It's a weird looking angel to me, but it is. There is some layering, you can see here. This is probably down to the belts needed to be tensioned and some other, and maybe a little bit of over extrusion as well going on there. There's a bit of rippling on the side, but overall I gave a decent print. Everything in their SD card has a raft. I don't like printing on rafts most of the time because rafts gives you really bad lower levels. This is actually the raft there that I haven't removed yet, or some of it. But all in all, the print quality was quite good. Now, I think a good test for a printer is actually vase mode to see how accurate a printer can be. So I actually did some tightening up in the belts and to make sure everything was ready to go. And I decided to kick off one of these rockets. As you know, I'm into science and astronomy, so I decided to print one of these rockets. And as in vase mode, it actually did a decent job. There is a little bit of rippling on the surface. That could be down to the slicer settings. But this is very, very basic. Again, I did no optimization. I just set the temperature, I turn on spiralize outer contour mode, and I ran it. And this is the result I got. So I'm actually quite happy. Even the text here along the fins actually came out really, really nice and clear. So overall, even up to the very tip, it's actually right up to the tip is really pointy. So it actually did a good job, and I was happy with that. So I decided to give it a torture test. Now, in the torture test, this is a good torture test. I really like this one. So in the torture test, it did okay. The surfacing was alright. It could have been a little bit better, but it wasn't bad. On these uprights here to do retraction distancing and so on, these came up pretty well. There is stringing there, which you expect without setting and optimizing your retraction settings. The dimensional accuracy of these was pretty good in both directions, so I think it's okay there. And its overhang tests that you see here did pretty well. I don't see any really bad issues with the overhangs. Now, I'm not too keen on the printer's cooling, but the overhangs did okay here. The one area that did suffer in a big way was the surface text. And again, it could be due to the printer being set for over extruding a little bit. So the surface text here did not come out super great, or over here. So these should actually give you all the readings and the size of these holes, and it didn't do a good job. But that can be fixed with optimizations. We do some calibration testing of the axes and some calibrations of the extruder. You can actually get that to where it needs to be. The overhangs, the front text is okay because it's large. There is some lining there, but again, that can be tuned out. Up here, it started going a little bit awry. The text on that is not fantastic. And then once you start going up into doing these angle testings to see how well it will print on overhangs, it printed fine up to 60 degrees on this one. After that, it started going a little bit, losing some filament on the bottom. The 75 degrees is a pretty steep angle. So, and on the larger one, again, up to 60, which is here, so it goes all the way up to 60 here, and it did well. But at 70 and 80 degrees, it really struggled, which I kind of wouldn't mind that, because if you're printing at that steep an angle, you can expect stuff to go wrong, because you're almost printing on thin air here. So up to 60 degrees on both of these, it did actually really, really well. So that gives you a good idea of what it can do. You might get it a little bit better on a 70-degree angle, but at this one here, it kind of struggled, and here, and then after that, as you can see, it actually really started getting stringy and printing on air, so it got pretty bad. But I'd be happy with a printer that can do up to 60 degrees of an overhang like this. That'd be kind of happy. I'd be happy with that. So all in all, it was a good printer. There's a few things I'm not a big fan of, but we can talk about that separately.